Good morning, everyone. My name is Leonard Lee. I'm the executive analyst and the only analyst at NextCurve. I have the pleasure of being on stage here with a good friend, Azita Arvani, who's formerly CEO North America of Rakuten, has a storied history at Nokia and a bunch of other places, right? She's like a big name in telco. And so why don't we get into this? What is Edge Continuum?
So let me start by saying that it's a great time to be in sensors. You ask me why. Number one, we are in physical AI era, right? So we've done a lot of things in digital AI, now in physical AI. And sensors are the gateway to that physical AI. Number two is that when it comes to physical AI, there is a big limit in how much data is already available, right? So on internet, you can scrape the internet and get all these great things and some not so great things for digital AI. But when it comes to physical AI, we still don't have that much data. So sensor data is super important. And number three is we are sort of moving past the AI training era to AI inference era. We actually have silicon that's AI inference specific. So you've seen the announcements from Google with TPU-8i and AWS Inferentia, et cetera, et cetera. So now we have silicons that are much lower power, inference specific, that can go closer to the sensors. So I think it's a great time to be in sensors. I'm sure I'll be happy about that. Now, what is Edge Continuum? At this conference and generally, people think about Edge AI as on-device AI. And then the other AI being going all the way to the cloud. So, for example, we were talking, you guys, I don't know how many of you saw the TDK keynote, but this is not a smart class, but if it was a smart class, we would have a lot of sensors around the periphery of this, and then they put a compute device at the nose of this device. So it takes some of that sensory information and processes it on this device, and then it sends some of it to the phone, right? So that's sort of like where we think about Edge AI. Or even Aura devices, for those of you who monitor your sleep. Some of that, not all of that sleep data goes to your phone. Only the stages of your sleep goes to this, so that it's outcome-based. So, and then there's the cloud. I'm here to say that there is another piece of this in between the, device/phone all the way to the cloud. So we can have the sensors and it could come to a hub. You could have compute at that hub. Or you could have like a private 5G hub there. You could have a hyperscaler edge private there. You could have telcos that have many edges, that have computes that are underutilized. They can be used for your AI. And then then you could go to the cloud. So there's this whole edge continuum that starts from sensing to then some sort of a hub, then various stages of edge that gets to the cloud. So when you think about your use case, it's really end to end and thinking about where you want to put that distribution of that intelligence. And it doesn't have to be one or the other. It could be a hybrid scenario.
Yeah, great. So, let's talk about some of the things that we're seeing here at the conference that should inform folks on where some of that placement makes sense, right? Obviously, sensors go everywhere. They're across various industries. When you look at quote-unquote intelligent systems, you're looking at a wide range of architectures, and also the economics are very different for different situations, whether it's smart car, smart factory, you're trying to instrument a machine, smart building, blah, blah, blah. There's this whole cornucopia of tools that you have, but then also the number of use cases are very, wide ranging compared to, let's say, what we're seeing in the these AI data centers, for instance, which are actually becoming great use cases for edge AI as well as IoT, because when you look at the operations aspect of a data center, there's a lot of physical environments that need to be managed in order for these data centers to be resilient, reliable, and support some of these very expensive workloads, training workloads, right? So sensors, IoT, AI, ironically, become important. So what are some of the things that you're seeing here that are informing the way you're thinking about that continuum?
Yeah, so a couple of things. First, for example, in the company that I work with, these devices now have the GPUs on them. For one reason, they go to places where they cannot be necessarily connected. So they cannot depend on connectivity all the time. So they have them on device. So now we have a lot of sensors like LiDARs and cameras and so forth. What I'm seeing here is the LiDARs, instead of being one big expensive LiDAR, we have like smaller, lower cost LiDARs, and you can have multiple of them that can then be on device, and that brings the cost of that down. And then you could just imagine that if the cost of the sensors go down, maybe you could have more budget for AI compute on device. So that's one trend that I'm seeing. But if you think about a venue, for example, I live in Los Angeles. For those of you who are NBA fans, Clippers, Steve Ballmer, the owner, started a new Clippers arena in Los Angeles. It started towards late 2024, and there are sensors everywhere. I mean, they know whether you're sitting in your seat, how much you're cheering. If you're loud, then you get more rewarded. All kinds of things. There's grab and go stores and everything and anything that could be visualized is done that way. When you walk in, you have these face recognition things, so you don't even have to have your phone. So that's on-device AI that you have it. And then with these grab and go type of stores, those are all connected via fiber to a local compute on the venue. So then that's where the AI is sitting. And then you have these low-level sensors, like for example in the seat, to see if you're in the seat, how noisy you are, and those are connected via Bluetooth and UWB to a hub, and that hub can then have AI running on it that could figure out what to do with the information that gets from the seat. So even in one venue, you have multiple ways that you could deal with sensor and where you put the AI for those sensors.
Yeah, a couple of things that I'm noticing, and these are probably like trends that folks in the sensors industry, MEMS industry already know, but from a physical perspective and device perspective, there's consolidation happening. So we see LiDARs that are multifunctional, right? And so you're starting to be able to make these things multi-purpose, right? And then on the virtualization end or the digital end of, or the AI-ish end of things, so if we're to think about edge AI, we're seeing new possibilities in sensor fusion, so different classes of sensors coming together to create either net new sensory capabilities or augment or make more flexible and extensible an existing sensor set. But then, one of the things that Karthik mentioned, going from just sensing things to understanding, so infusing some of that cognitive capability much closer to the sensor, which I think is a counterpoint to what we traditionally have thought of in the IoT world, where we're sending streams of data up, right? And so going forward, as we look at the edge continuum, my view is that what you folks are working on here and what we're seeing here is a counterpoint to what we traditionally thought of in terms of how we architect intelligent systems or cognitive systems, what have you, whether it's a smart factory or smart homeware. And, to your point, this is all about localizing things on device for all the benefits that it has archetypically been represented to bring in terms of security, privacy, latency.
Yeah.
Right.
Yeah. And then one other thing I wanted to mention that I think I haven't heard that much being talked about here is about synthetic data, right? So we would like to have insights and outcomes instead of the whole amount of data being transferred from sensors to next stop along the way. However, if you do want to keep that sensor data for archival purposes or further training or some other way, you could actually compact that data via a model at the source and then just transfer the model over. You could think of it like freeze drying your data and then transferring it over, so then the cost of transfer is much lower, and then you unfreeze it at the destination. So that's another thing that's available, and those companies are there, and I advise one synthetic data company, but there are others as well. So we should think about that as well. So it's not just, you either send all of the sensor data over or you just send the outcomes. You also have a way of capturing the essence of that data for further AI training or other uses.
Yeah, we see some of that out there in terms of like digital twinning simulation, right? So with synthetic data, I mean, the way I look at it, it's like once removed from the sensor. So if you're doing digital twinning, you're only going to be able to capture live data, real-time data that's coming off of sensors, right? And you're making a great point. The next step, it's a synthetic data, you're going to create a model in a simulation, and that's what we see in automotive, right? Quite often.
But what I'm saying is not using synthetic data to generate new cases, which is one use case of synthetic data, but actually synthetic data to capture what's already generated.
Yeah. Okay. And so we have 1 minute, less than 1 minute. Any final thoughts? Any, points that you want to, points of inspiration that you want to share with our wonderful audience here?
Yeah, I mean, the thing about sensors, as we heard from the last presentation, sensors are not just there to sense, but they're there to think and understand. And there are so many tools available now, and edge is really not just one place. It goes, you have many, many options. And actually, the challenge is, how do you use that option? And these could be dynamic as well. You don't have to start somewhere and just be stuck with it. You have orchestration software that can move your workloads around depending on, your SLA, latency, costs, all the things that we talked about.
Yeah, and my closing remark here is a bit of inspiration for everyone here, a reason to get excited. So you've seen, like, with the AI trend, how from a silicon perspective, we got excited about the accelerator, and then it became about networking, and then it became memory. This is all about how as we move away from, the focus moves away from, pre-training and post-training, all this stuff, toward inference and agentic, and now physical. You have all these constraints, right? Well, when you get to physical, you guys are, with the sensor, be the constraint, right? And so it's very possible in the very near future that, sensors will matter a lot, because you need the IoT and you need that understanding in order to hydrate these physical AI models. And then this ambition to create world models, it's all going to be based on physics and observations of the physical world, and that only happens through sensors. So anyways, love to leave that with everyone. And hey, Azita, it's great hanging out with you as always.
As always.
I love the topic, and look forward to continuing this conversation about the Edge Continuum. And thank you everyone for attending, and we appreciate your attention. Thank you.
Thank you.